Hello, welcome to Anybody Can Learn. Today we will solve a problem based on the k-fold cross validation. Let's see the question. For a data set with 1200 data points and 40 features, 6-fold cross validation will perform validation of how many models? Options are 5 model, B 6 model, C 40 models, D 1200 models. So let's understand it step by step. So what is a data set? A data set is a complete collection of data. We can think of it like a Excel data set. The entire table is called a data set and each row of the data set is called data point. So A18 480 is a one data point. B19 519 is another data point. Similarly, C20 370 is another data point. Data point can also be called as example or instance or sample or observations. In our specific question, there are 1200 data points. That means there are exactly 1200 individual rows. Now understand what do you mean by features. Features are input variables that helps to predict the output. Each column describing the input is called as a features. Suppose we want to predict a house price and possible features are area, bedrooms, bathrooms, age of house and parking space. So these are called as a features. In our questions there are 40 features. That means every data point has exactly 40 input values. Features act as a clues. We can think it like features act as a clues we use to find the final answers. Why do we split the data? Suppose teacher gives a student same question during the practice and the final exam. Student will score very high because they have already seen the questions. So this does not measure the true learning. Similarly, in machine learning, we cannot evaluate the model using its training data. The performance may look unrealistically good if we use the same training data to evaluate the model. To test how well a model generalizes to new unseen data, we must split the data. So, the main reason to split the data is to test how well a model generalizes to new unseen data. There are three types of the data splits. One is training data, another is validation data, and third is testing data. Training data used to learn the model and model adjusts the parameters also called as the weights during the training data. We can think of it like the model's study material. The training data, we can think of it like it is a study material for the model. Validation data. Validation data is used to evaluate the model during the development. Validation data checks for overfitting and help to change hyperparameters. We can think validation data as a practice test. Another type of data is the testing data or test data. Test data is used after the model development is complete. Unbiased estimate of final performance on unseen data. We can think test data as the final examination. Now understand what do you mean by cross validation. Cross validation is a technique for evaluating a machine learning model. We repeatedly train and validate the model on a different subset of the data. We do not use just one train and the validation split. Instead of that, we create several different splits. This ensures that every data point gets a chance to be used for validation. Now understand what is a k-fold cross validation. In k-fold cross validation, we divide the data set into k equal parts. Each part is called as a folds, and repeat the following process exactly for k times. That means use the one fold for validation and remaining k minus 1 fold for training. Repeat this process for k times. By this way, train exactly one model per iteration. The number of the folds are called as a k. K means number of the folds and size of each fold is n divided by k, where n is the total number of the data point and k is the number of the folds. Now understand the information given to us. In our questions, the data point, that is capital N, is given as 1200 and number of features as a 40 and number of folds, that is k, is given as 6. Please notice that we have given the 40 features, but remember that features do not affect the number of the folds or models. The number of the features only tells us how many input variables each data point has. So, while calculating the folds or models, we do not need number of features. Now calculate the models and fold size. The total number of trained and validated model is equal to k. K is the number of folds. In our example questions, we have given k as a 6. So the number of the model is 6. Now calculate the number of fold size. Fold size is calculated by the formula n divided by k, where n is total number of data points and k is fold, number of the fold. So total number of data point is given as 1200 and fold number of fold is 6. So it is 1200 divided by 6, that is 200. So fold size is 200. That means each fold contains exactly 200 data points. Now calculate validation data. In each iteration, exactly one fold is used for validation. We have given n, that is number of data point, as 1200 and k fold as 6. So validation size is n divided by k. Just now we found that the fold size in the previous steps. So n is 1200 and k is 6. So 1200 divided by 6 is 200. So validation data is 200. Notice that validation size is always equal to exactly one fold size. Now calculate training data. The remaining k minus 1 fold are used for the training. The training size is calculated by the formula k minus 1 divided by k whole multiplied by n. We have given k as a 6. So 6 minus 1 divided by 6 whole multiplied by 1200. 6 minus 1 means 5. So 5 divided by 6 multiplied by 1200. Therefore, it is 1200 divided by 6 is equal to 200. So 200 multiplied by 5 is 1000. Therefore, training data is 1000. Training data 1000 plus validation data is 200, that is 1200. So it matches our original dataset size, that is n. So in a 1200 data point of dataset with a k with 6 fold, each model trains on 1000 data points and validates on 200 points. Let's see some formula. So validation function is 1 upon validation fraction is 1 upon k, where k is number of fold. So number of fold is equal to k is equal to 1 upon validation fraction. Fold size is calculated by the formula n by k, where n is a total data points and k is a number of fold. Training size is calculated by formula k minus 1 divided by k multiplied by capital N, and validation size is calculated by the formula n by k. Number of fold is equal to k. Now solve the another questions based on a k-fold cross validation. Question 5. For a data set with 2500 with a 2400 data points and a 60 features, assume that you keep 75% of data for training and remaining 25% of data for validation during a k-fold cross validation. And the question is, how many models will be validated during the cross validation? Options given are A 3, B 4, C 25 and D 75. So understand the questions. In a questions we have given total number of data points, that is capital N, as 2400, and number of the features F is given as 60. This means that each data point contains 60 input features. We know that the number of the features does not affect the number of the folds or number of the models. Also we have given the training percentage as a 75% and validation percentage is 25%. That means we are using 75% of the data for training and 25% of the data for validation. First convert the percentage into the fraction. 25% means 25 divided by 100. So divide both the numerator and denominator by 25. So 25% means 1 by 4. This 1 by 4 means a data set has been divided into 4 equal parts. Each part is called as a fold. The validation data is always given by the formula 1 upon k of the data set. So validation fraction formula is 1 upon k. Since 1 upon k is 1 upon 4, therefore k is equal to 4. So number of the folds is 4. Number of fold is formula calculated by the formula k. Number of fold is equal to k. So substitute k is equal to 4. Therefore number of models is 4. Let us see another question. Question number 6. For a data set with 5000 data points and 80 features, how many models will be trained during the leave one out cross validation? Option A is 1000, option B is 50, option C is 5000 and option D is 20. So first understand what do you mean by leave one out cross validation. Leave one out cross validation is a special case of k-fold cross validation, where each fold contains exactly one data point. So validation set contain one data point and training set contain all remaining data points. Why it is called leave one out? Because here we are leaving one data point out for validation and we are using all remaining data point to train the model. Repeat by leaving out a different data point and the process repeats until every data point is used once. So leave one out means leave one data point for validation. In our questions we have given total data point, that capital N as 5000 and number of the feature as 50. In leave one out cross validation, if there are n data points, then the number of the folds become k is equal to n. So formula is k is equal to n for leave one out cross validation, where n is given as 5000. Therefore after substituting 5000 we will get k is equal to 5000. So the data set is divided into 5000 folds. Therefore the number of the models trained is 5000. In ordinary k fold, each fold has many points, but in leave one out cross validation, each fold contain only one data point, and we know that the number of the model is equal to k. In ordinary k fold, fold size has many data point, but in leave one out cross validation we have exactly one data point, and number of fold is calculated in ordinary data point as a validation of the fraction is 1 upon k, whereas in leave one out cross validation k is exactly equal to n, and number of models in ordinary k fold is equal to k, while in leave one out cross validation number of the models equal to total data point, that is capital N. So formula used in leave one out cross validations are number of fold, that is k is equal to n. N means total number of data point and training data is n minus 1 and number of the models is capital N. Thank you.